Welcome to Precalculus Algebra, Transformations of Functions Part 2. And in this video we're going to be given the graph given the equation of a curve, and we want to graph that curve. And we're going to do so using transformations, not by plotting a table of values. So let me remind you, last time in Transformations of Functions Part 1, we listed our 10 transformations. So given a function f of x, these were our transformations. So if you add a positive constant, in this case I give the example of adding 2, the effect is shifting the graph up 2 units. If you subtract a positive constant, you shift down. If you replace x with x take away a positive constant, in this case x take away 2, you shift to the right horizontally. If you replace x with x plus 2, you shift 2 to the left. If you multiply your function by -1, you reflect it across the x-axis. If you replace x with -x, you reflect across the y-axis. If you multiply your function by a positive constant greater than 1, so I gave you an example of 2, but what's important is that it's greater than 1, you get a vertical stretch. If you multiply your function by a positive constant, so it's positive but less than 1, so in this case 1/2 is less than 1, you shrink your graph vertically. If you replace x with a positive constant greater than 1, multiplied by x, so x has been replaced by 2x, you get a horizontal shrink. And here you're replacing x with a positive constant multiplied by x, where the positive constant is less than 1. In that case you get a horizontal stretch. So the key to graphing our functions is going to be to, over here, we're going to build our function using a basic function that we know and love, together with only these transformations applied one at a time. And that's the key thing to remember. You're building your function up one at a time. And let's see how this works. Okay, here we're going to graph y equals x minus 3 squared plus 2 using transformations. And so as I mentioned, you start with a basic function. In this case, it's going to be y equals x squared. And the question is, how do you take that and build it up one transformation at a time to get this? Well, the first thing we're going to do is, we notice that it's x minus 3 that's squared, not just x squared. So we're going to replace x with x minus 3. And we get y equals x minus 3 squared. Okay? Now that is a transformation, right? So according to our chart over here, and I recommend that you memorize or print out this chart, right, we're in this transformation here, right? X has been replaced with x minus 3. And that means that we shift 3 to the right. So the graph of this is going to be the graph of that, but shifted 3 units to the right. And finally, what do you have to do to get to our final function? Well, clearly you have to add 2, and that's another transformation. So it's y equals x minus 3 quantity squared plus 2. Okay, now notice that this, let me make sure that looks like a plus 2 right there. Okay, so notice that it's this graph that's added, that is shifted up 2, right? So we added 2 to this to get to that. So we don't add 2 to this, we add 2 to that. Okay, and I created 3 charts here, 3 coordinate systems, because we have 1, 2, 3 graphs to draw. And the first 2 graphs are just going to help us get the last graph. The last graph is really the most important, or it is the graph of the function we want. So I'm going to graph these 2 graphs, or these 2 curves. I'm going to graph them dotted. Let's pick some points. So x squared goes through 0, 0, it goes through 1, 1, and it goes through 2, 4. Okay, let's label all these points. So this is 2, 4, and this is 1, 1. 0, 0 will leave as it is, it's the origin. Negative 1, 1, and we also have negative 2, 4, which we'll label as well. Okay, and so this is the graph of x squared. So what we're going to do then is we're going to, or let me go ahead and draw this in for you. I put a few points, but dotted, this is the graph of the parabola x squared. Okay, so what's happening? This graph is being shifted to the right 3 units. So here we're going to graph x minus 3 squared. Okay, that's y equals x squared and y equals x minus 3 squared. So these points all move to the right 3. So 0, 0 is going to move to 3, 0. And this point, 1, 1, if you add 3 units to the x-axis, or the x-coordinate, it's going to be 4, 1. So we're going to get this point over here labeled 4, 1. Okay, and this point, 2, 4, if you move it 3 units to the right, it's going to become 5, 4. So 5, 4. Maybe right there. Let's see, this point, negative 1, 1, move it to the 3 to the right, becomes positive 2, 1. So let's label that without making a mess. 2, 1. And then this point, you move it 2 to the right, and instead of negative 2, 4, oh, sorry, we're moving 3 to the right. So I moved 3 to the right there, and I got 2, 1. If I move this 3 to the right, I get 1, 4. So I add 3 to the x coordinate. So it's going to be 1, 4. So right here. So that's the point, 1, 4. Okay, and then I draw this dotted as well, and that's going to be this. Okay, and that's this graph but shifted to the right 3 units. Finally, what's going to happen to all these points? Well, to go from the graph we just graphed to the next one, y equals x minus 3 squared plus 2, you add 2 units to, or you add the value of 2 to all the points you had here. And when you add 2, that increases the y coordinate by 2. So 5, 4 is going to be 5, 6. Let's plot that here. So that's now the point 5, 6. 4, 1 is going to become 4, 3. Adding 2 to this, right? The y coordinate, 3, 0, now becomes 3, 2. This point, which was 2, 1, add 2 units, becomes 2, 3. So 2, 3, that's going to be this point, 2, 3. And this point, 1, 4, is going to become 1, 6. So 1, 6 is over there. Okay, now this graph, this is the one we want, right? So let's go ahead and draw that in solid. So there's the graph we want. So let's recap what we did. We started with a function we knew, x squared. We shifted that to the right 3 units, and then we shifted that graph up 2 units. Okay, so it's a constant transformation of transformations to get to your final graph. Okay, let's take try another one involving the square root. Okay, so here we're going to graph y equals 1 take away the square root of x plus 2 using transformations. And once again, you want to start with a function you know and love. So that function will be y equals the square root of x. So we start with y equals root x. And from that, what would the first transformation be? Well, we're going to replace x under the radical with x plus 2. So we're going to have, next is going to be y equals the square root of x plus 2. Actually, why don't we just draw these where they're going to be? So let me just erase that real quick. So root x is going to be graphed right here. And then the next one that we're going to have is y equals the square root of x plus 2. Okay, so now the effect of that is to shift this graph 2 units to the left, right? And I can see that from my table of transformations over here. Next one is going to be to multiply the function by negative 1. So over here we're going to have y equals negative square root of x plus 2. And the effect of that, according to this, is to reflect the graph we just had across the x-axis. And then finally we're going to add 1 to get our final graph, y equals 1 take away the square root of x plus 2. Okay, so starting with root x, a few points we know, 0, 0, 1, 1, let's label that. So that was a point 1, 1. And then the point 4, 2. Okay, and then when you draw a dotted through these points, you basically have half a parabola on its side. Okay, that's the graph of the square root of x. So according to the next transformation, what happens? Well, this says that you move all those points 2 to the left. So 0, 0 is going to move to the left, so it's going to give rise to negative 2, 0. 1, 1 is going to move 2 to the left, so it's going to be negative 1, 1. So negative 1, 1 is right there. And then this is going to move 2 to the left to give 2, 2. I'm just subtracting 2 from the x coordinates. And then I get the new graph, right? Been shifted 2 to the left. like that. Next transformation says, hey, take what you had and multiply it by -1. Okay, what happens when you multiply a function by -1? Well, you reflect across the x-axis. Now, in the reflection, this point stays the same, right? -2, 0 doesn't change. But when it's been reflected, the point -1, 1 becomes the point, well, let's see what happens. The x-coordinate stays the same, but when it reflects, the y-coordinate, instead of being 1, the y-coordinate is going to be -1. So -1, -1 is going to be down here. Yeah, and then when this point, which was, I should label these points actually. This point was -1, 1, right? And this point was 2, 2. So you can see what we're doing. So -1, 1, that the y-coordinate changes to -1. So it's -1, -1. And then here the y-coordinate is going to change to -2. So instead of 2, 2, it's going to be 2, -2. So 2, -2 down here. 2, -2. And then when I draw that in dotted, it's going to look like so. Okay, and that's the graph of this, but just reflected across the x-axis. And then finally what happens? Well, you take that graph and you add 1. That means you add 1 to all these points. So instead of -2, 0, it's going to be up 1. So -2, 1. Let's label that. So -2, 1. Add 1 to the y-coordinate here. Well, the y-coordinate is -1, and when you add 1, you get 0. So it's -1, 0. Okay, so let's label that. -1, 0. And then when you add 1 to this, it's going to be 2, -1. So right here, that's the point. 2, -1. Okay, and then this is going to be our final graph, so I'm going to draw it solid. Let's go ahead and do that. Okay, and so there's our final graph, right? Drawn in solid. So we started with root x, we shifted that 2 units to the left, we reflected that across the x-axis, and then finally we took that graph and we shifted it up 1 unit to get our final graph. Okay, so for our next example, we have to first do a little preliminary work. Okay, let's say that you had the absolute value of 2x minus 6, and you wanted to build it up from the basic function root x. What would you first do? Well, you might be thinking to yourself, okay, I'm first going to replace x with 2x, and you get 2x. But then what? Now, if you said that you're going to replace x with x minus 6, you'd be wrong, because that would be the absolute value of 2, and if x just gets replaced simply with x minus 6, it looks like that. Whoops, change that to a parenthesis. Right? And that's not what you want. So these are not the same. Okay, so what this illustrates is that when you create transformations, you have to do so in such a way that you get exactly the same function you started with. So instead, we're going to note that we can write the absolute value of 2x minus 6 in the following way. Absolute value of 2 multiplied by x minus 3. So these are the same thing. And then we can build that up, because if we start with the absolute value of x, we can get the absolute value of 2x. I'll replace x with 2x. And then I'm going to replace x with x minus 3. So that's the same as the absolute value of 2 times x minus 3. And of course, this of course is the same as that. So it showed that we can build that up using transformations. Now, those transformations, of course, the order in which they're applied and the type of transformation, they all correspond to the chart over here. So my point is that sometimes when you have a function, you have to put it in a form where you can then build it up using this table of transformations. And that's true for this next example. Okay, here we're going to graph y equals negative times 1/2 times the absolute value of 2x minus 6. And as I mentioned a moment ago, let's first write that as negative 1/2 times the absolute value of 2 times x minus 3. And then in that form now we can apply transformations. So the basic underlying function is root x, or sorry, absolute value of x. So here we have y equals the absolute value of x. And then what's the next function going to be? So we're trying to build up to this. So it's going to be y equals the absolute value of 2x, right? I'm just doing one step at a time. So that's the second function. And then we're going to replace x with x minus 3. So the next one's going to be y equals the absolute value of 2 times x minus 3. And then what? Well, you might think you're going to multiply by negative 1/2, But this chart over here says that those are two separate steps, right? The constant out in front that you multiply by, that constant's always positive. So we're first going to multiply by 1/2, and then separately we're going to multiply by a -1. So next graph is going to be this multiplied by 1/2. Let's write that here. So y equals 1/2 times the absolute value of 2 times x minus 3. And then finally, to get our final function, we're going to multiply that whole thing by a -1. So y equals -1/2 times the absolute value of 2 times x minus 3. Okay, so let's go ahead and do this. So just start with the absolute value of x. We're just going to pick 3 points, -1, 1, 0, 0, 1, 1. And we're going to draw a dotted through those points, right? It's just the absolute value function. What happens next? Well, x has been replaced with 2x. And what's the effect? Well, it's a horizontal shrink. You compress by a factor of 2. So at this point, let's label it 1, 1. And this point here is -1, 1. When you shrink horizontally, instead of 1, it's going to be 1/2. Right? The y-coordinate doesn't change. The y-coordinate doesn't change, but the x-coordinate becomes 1/2. And same with this x-coordinate, becomes -1/2. So over here, it's going to be right at this point, which is going to be 1/2, 1. X is 1/2, y is 1. And then we still have 0, 0. And this point right here is going to be -1/2, 1. So -1/2, 1. Okay, and then dotted through those, it's been compressed. Somebody pushed on both sides of it and compressed it horizontally. Next transformation is to, well, what's happened? X in this graph has been replaced with x minus 3. That means this curve has been shifted 3 units to the right. So you take the x-coordinate and you add 3. So 1/2, 1 becomes 3.5, 1. Let's write that down. So it's going to be 3.5, or 3 and 1/2, 1. 3 and 1/2, comma 1. You can write it as 3.5, but I like to write it as 3 and 1/2, 1. So it's right there. Okay. This point, 0, 0, now becomes 3, 0. And that point, -1/2, 1, if you add 3 to the x-coordinate, it becomes 2.5, 1. So that point, let me write it over here, is 2.5, 1. So 2.5, 1 is right there. Okay, so then you draw that dotted. Okay, and what is that graph? Well, it's this graph just shifted to the right 3 units. Go to the next one. What happens? Well, you multiply by a 1/2. And what's the effect of that? Well, according to this, it's a vertical shrink. So what happens is the y-coordinate goes from 1 to 1/2. So instead of 3.5, 1, it's going to be 3.5, 1/2. So let's write, so 3.5, 1/2, right? It's been shrunken. So let's write 3.5, 1/2. And then the this point stays the same, 3, 0. What's going to happen to that point? Well, instead of 2.5, 1, it's going to be 2.5, 1/2, right? All the y-coordinates get multiplied by a half. So 2.5, 1/2 puts us right there. So let's label that point. 2.5, now it's 2.5, 1/2. And then dotted. Okay, and then finally, what do you do to this graph? Well, you multiply it by a -1, right? And the effect is that when you multiply by a -1, you get a reflection across the x-axis, which means that instead of 3.5, 1/2, it's going to be 3.5, -1/2. So 3.5, -1/2 is right there. Let's label that point. It's 3.5, comma, -1/2. Okay, and in this point, 3, 0 stays the same. It's kind of nice. Now, that point, which was 2.5, 1/2, becomes 2.5, -1/2. So it's right here. It becomes 2.5, -1/2 when you reflect it. So 2.5, -1/2 right there. Okay. Now this is our final graph. Okay, so let's draw that in solid. So the graph is going to look like this. Like that. And like that. Okay. All right, so what we see is that we graph complicated functions using step-by-step transformations. And you have to make sure that every transformation you use corresponds to one of these 10 transformations over here in this chart. So I recommend maybe writing this chart down, printing it, memorizing it, so that you can break things down one step at a time. Okay, until next time.